Hello and welcome to 3.6. So in 3.5, we spent time talking about solving systems of equations. We learned three different ways to solve them. We use linear combinations, we use substitution, and then we use Cramer's rule. So today we're going to look at taking real-life situations and modeling them using equations, and then solving for those variables just like we did last time. But our first step, okay, when we look at a problem, as it says here, is to define your variables. So we look at our situation, we have 8 pens and 7 pencils cost $3.37. Well, 5 pens and 11 pencils cost $3.10. So how much does each pen or pencil cost? So what we're trying to determine is the cost of a pen and the cost of a pencil. So if we do X, okay, is the cost of a pen, okay, and Y is the cost of a pencil. And we know we sold 8 pens and 7 pencils for $3.37. So if we take 8 pens and we add 7 pencils, we know that that has to equal $3.37. Okay, if we have 5 pens and 11 pencils to get to $3.10, so 5x plus 11y has to equal $3.10. Now, at this point, it's really up to you. You can use any one of the three methods that we talked about yesterday in the last set of lessons. You can use linear combinations, which is the one that I'm going to use on this particular one. I have here, right, 8 and 5x. So if I multiply one of these by a positive and one of these by a negative to get them to be equal to one another, I can then cancel out the entire thing. So if I stick with the top one being positive, I want to multiply it by 5, and then the bottom one I can multiply by a negative 8. So when I do that, my top one becomes 40x plus 35y equals 337 times 5, which is 1685. Okay, and then on my bottom one, if I multiply by a negative 8, I get negative 40x and then minus 88y equals, and if you do a negative 8 times $3.10, that leaves you with a negative $24.80. So if I add these together, right, my x's will now cancel each other off. If I have a positive 35 and a negative 88, that gives me a negative 53y, which I'm not, it's okay that that's negative, right? Because when you look to the other side, we're also going to have a negative number. So since we have the negative on both sides, it's going to give us a positive overall answer once we divide it out. So if I do the 1685 and I add to it a negative 2480, that gives me a negative 795. If I divide both sides by a negative 53, that gives me y equals $0.15 or 15 cents. Okay, so right, I'm not done though, right? Because once you find the cost of a pencil, which was y, we have to go back and find the cost of a pen, which is x. So I can just put this back into my original equation, 8x plus 7 times 0.15, because that was my y. Substituting it back in has to equal $3.37. So now if I do 7 times 0.15, that gives me $1.05. So 8x plus 1.05 has to equal 3.37. I can now subtract $1.05 from both sides, and that gives me that 8x has to equal $2.32. So if I then divide both sides by 8, I get that x equals 0.29. So at the end of the day, my final answer would be my x, which is my pens, right, cost $0.29, and my pencil cost is $0.15. Now, I do want to quick point out, right, that we left this in terms of dollars, so it's 0.29 and it's 0.15. If you change it to cents, it's important that you make sure, right, you get rid of your decimal place and you put cents. But as a general rule, we always want to leave things in the form at which they came to us. So this came in terms of dollars, so we're going to leave it in terms of dollars. All right, on to example 2. Example 2 says, Anne can paddle her canoe 15 miles downstream in 2 hours. The return trip upstream takes 3 times as long. What is the rate of the current? So let's think about this in terms of distance equals rate times time. Okay, so her distance, right, it says she paddles 15 miles. So distance is 15 miles on the way down. Her rate, we don't know, but her time was 2 hours. So we have distance equals her rate times her time of 2 hours, right? So this is going down and this is coming back up. So we have 2 things that we have to take into consideration. We have to take into consideration how fast she paddles and how fast the current is either pushing her forward or pulling her back. So if we use our 2 variables, okay, we use our x is her paddle speed. So this is paddle speed. Oops. Okay, and y is going to be the current, right? On the way down, right, this r, right, is going to be her paddle speed plus the current speed times time, which was 2 hours. Okay, on her way back up, right, we're going to have the same idea, except now we have the rate at which she's moving times, it says 3 times as long. So 2 times 3 is 6. Well, this r here, right, for this case, her rate is going to be, right, the x minus y. Right, because on the way down, it's pushing her. On the way back upstream, right, she's fighting into the current, so it's pulling her backwards. Okay, so now what I have to do is I have to distribute this, right, to each one. Okay, so 15 equals 2x plus 2y, and 15 equals 6x minus 6y. Now, hopefully you guys notice right away that we have this positive 2y and this negative 6y. So if I multiply this top one by 3, that would give me 45 equals 6x plus 6y. And then I would have my 15 equals 6x minus 6y. So when I now use linear combinations to add those together, that gives me 60 equals 12x. I can then divide both sides by 12, and I get that x equals 5. Okay, so her paddle speed was 5 kilometers per hour, or miles, excuse me, it's miles. Okay, so this is 5 miles per hour, but we need to know what the current speed is. So I just put this back into one of my original equations. 15 equals 5 plus y times 2. So 15 equals 10 plus 2y. So now if I subtract 10 from both sides, I get that 5 equals 2y, divide both sides by 2, and y equals 2.5. So this shows me that her paddle speed was 5 and that the current paddle speed, or the current speed, was 2.5. So for my final, right, my paddle speed, okay, was 5 miles per hour. Okay, and the current speed was 2.5 miles per hour. So hopefully that helps you out. You have some homework problems to get to. So have a great day, and we look forward to seeing you in class.